Okay, here we go. Welcome to another presentation from the Technical Technician from Diagnation. Today we're going to talk about something a little unique. It's called using a scope as a multi-channel ohm meter. Now, this is one of those situations where we want to monitor circuits that may be getting fed when they shouldn't be, causing it could be a plethora of different situations. I have seen cases where you turn the headlights on a clear evening and the wipers come on. I've scoped map sensors and seen ignition primary in the map sensor circuit. I have seen other situations. I have seen the network on a Ford, the SCP, which is about 41,000 bytes per second, bleed into a mass airflow sensor signal wire and throw the PCM a major curveball, and it overfueled the engine extremely. Nonetheless, this situation is pretty simple. It looks a little convoluted. I will explain. It'll make it easier as we go through it. First of all, take a snapshot of this. Probably the best thing. And like in most of my videos, you want to take a snapshot and use it as you watch the remainder of the video, because it will simplify things. Basically, we're looking at a circuit, and this technique can be used on any type of circuit. It doesn't have to be on engine control. It could be an accessory. It could be something else. Basically, we're gonna look at 8 channels, and we're gonna look at the injector circuit and the ignition coil trigger circuit on the 2004 Honda Accord. We are disconnected from the PCM connector A and B, where the injectors and the coils go in. We are disconnected at all 4 injectors and all 4 ignition coils. We have the battery disconnected. See, I put question marks there. You may want to consider doing that. It's a variable. It depends how nasty the problem is. Sometimes you may just want to disconnect the battery and then deal with the resets later. But anytime we're in a situation like this, this is a kind of a nasty situation. We've probably been through the ringer. This car may have had multiple parts put on it. This is a condition where, as we can see, electricity will bleed over to a circuit where it's not supposed to. As we can see, look at connector 201 and look at all that runs through there. And believe me, on this Honda, there are other things that run through there. There's a myriad of sensors and O2 sensors, air fuel ratio sensors, canister purge solenoids. If you think about a connector, if it's vulnerable to corrosion or moisture intrusion or capillary action from fluids, heat, thermal cycling, where the insulation is compromised, where voltage will leak over to a circuit where it's not supposed to be. That's the kind of situation we're going to try to search for. As you set this up, you want to use a methodology. Always take the circuit that's working normally, and we're going to feed that. In a case like this, we're going to use a 9-volt battery. We will feed that circuit, and we will see if the circuit will feel that 9 volts when it's not supposed to. We will shake the wiring harness and see where the circuit's picking up the 9 volts. That's the part of the circuit we know we're compromised, where there's a copper to copper through some conductive medium, whether it be direct copper through moisture, where the circuit would be getting fed when it's not supposed to. So basically, in this setup, I have a 9-volt battery, and I will be feeding each circuit just as a basis to see what we're looking at. We will feed at the PCM. PCM is disconnected. You will see the power on one of the circuits. One channel is on the scope, and then I'll go down the line, and you will see it on each channel, just to get a reference point of what it looks like on the scope. So here we go. Let's go to the scope, and we're going across. We got one more thing. I'm sorry. I did this for simplicity. You may want to notice this to make it easier. We are on 8 channels. Our A, B, C, D, E, F, G, H. Channel A is injector 1, channel B, injector 2, channel C, injector 3, channel D, yellow, injector 4, and down the way on the coils, the 5th channel, channel E, purple, is coil 1, channel F is coil 2, channel G is coil 3, and channel H is coil 4. Those are the trigger wires coming from the PCM to trigger the coil. They are not power and feed. We are disconnected on all 4 coils and all 4 injectors. So let's hook the scope up, and I will go down the line, and I will feed each signal. It's 9 volts, and then we'll kind of analyze it. Alrighty. Okay. can see the scope. Okay. Okay, we see all 8 channels running across the scope. Everybody's low, okay? A, B, C, D, E, F, G, H is low. When it gets fed, it will see about 9 volts because we're dealing with a 9-volt battery. We'll kind of keep our scales even so we can watch. And I will go down the line and I will feed A through H one at a time just to get a reference point of what it looks like. So here we go. We're gonna feed. Start with the blue guy and go down the line. In a gray area. Okay, let's analyze. See what we did. Just kind of roll back and analyze each thing. This is just a kind of a test setup to know that we what we look like. Okay, let's start out. This is our first channel. This is blue is high, which I started to feed blue. Okay, the next one should be red. As it is, you can see red here. The next one should be green. There's green, okay. The next one should be yellow. Gold, I kind of morphed the channel. It's more gold than yellow, as you see on your illustration, just because it's a sunlight issue. Once I go yellow or I go gold, depending on the day. That is the 4th channel, D, gold. 5th is purple. You can see it there. I'll see if I got caught in the gap. Yeah, no, I didn't. There's our purple guy. Okay, the 6th is gray. Well, let me go back. I kind of missed the gray guy. You can see him right there. I got caught in the gap, which happens with the scope every now and then. But there's our gray guy. That is our 6th. Our 7th is orange. And our final one is burgundy, the 8th one. So I just kind of fed that. And then I played with the burgundy a little bit and sort of kept it on and off. But now I'm going to turn the scope back live. And now we got to consider ourselves in a situation where we have some bleed over voltage. We're trying to diagnose it on the vehicle. We have to look at all the vulnerable spots. Look at hot spots. Look at where harnesses may be rubbing, where brackets have been disconnected or loose, or hinge spots. That's a big thing. Door, rear hatchbacks that pivot, doors that open and close, where the harness is constantly flexing. Exhaust manifolds, that's another area where the heat gets to the insulation and it melts it, or chemicals spill and that copper gets compromised and it bleeds over. I'm going to create a situation. I'm going to feed blue and we'll take a look at it go. I'm just going to feed blue the 9 volts and see what happens and create an issue. Okay, we're feeding blue, and we're high on blue. You see the blue voltage go up. Now, if we were in a situation where we were scoping a car and we saw something on an injector circuit that shouldn't be there, we want to feed our normal circuit, which is the blue circuit, which would be the injector circuit, and see if we get an interloper. Somebody kind of entered the equation that shouldn't be there as we roll across the screen. I want to go to a longer time base because let's go to 1 second and let's kind of watch the action as it goes on. I'll create a situation. I won't tell you what I'm creating. We'll kind of create a situation, then we'll analyze it. Okay, what do we got here? Let's kind of analyze that. Let's stop the scope and look and see what happened. Let's kind of look at our situation. Roll it back. Yeah, we see something going on. Okay, we see blue. I shook the harness. I took give it a visual inspection. I have the scope hooked, and we see some action. We see a bleed over. We can definitely see it on the fourth channel D. There's gold, and gold is high right there, which could be that's the part of the circuit we want to we'd have under suspicion. Also, along with gold, looks like there's another guy. Looks like channel H. It looks like Burgundy got a little into the part. Burgundy joined the party. It kind of got there. It kind of came and went. Anybody else in the doesn't look like, but nonetheless, we would go after that part. If we saw that, we would definitely consider that an issue and try to chase that part of the circuit. There could be bleed over there. Anybody else? Let me just take a quick gander and look. Doesn't look like anybody else. Okay, I'm gonna get everybody back to normal, and then we'll do it. We'll take another scenario. Okay, now we don't always wouldn't feed the same circuit. We'd have to use some logic in the circuit we were to hot feed. So I'm going to feed another circuit this time. I'm going to feed the purple circuit. That is an ignition coil. That is ignition coil 1 signal wire. So let me make a little switch, and we'll go to that guy. Okay. All right. Looks like we're high on purple. We're going to feed that circuit, and we're going to see if anybody would be interfering with that circuit. So we're feeding the 9 volts into only purple now, and watch the scope as things change. Okay, a little situation there. Okay, sometimes you have to work to get that problem to act up. So let's kind of slow it down and go back to our first scenario. Okay, we we're feeding purple, okay? Well, and that is, purple is our ignition coil 1 trigger circuit. Let's roll down. We're shaking the harness and seeing what's happening. Okay, we got a little action with blue. Where blue bled over into the number 1 ignition trigger. That is the number 1 injector. That could definitely create a problem because both those are triggered signals, but at different times. That could cause a hiccup. That could definitely cause an issue on a running car where we have a ground side controlled injector feed into a triggered side control ignition coil. Just bear that in mind. That's a situation right there. Anything else? And then now we got another situation, okay, where the number 4 injector was fed over from the number 1 ignition coil. That would create another symptom, as we can see. And nonetheless, just bear that in mind. There's a myriad of different ways you can use this. This is you want to look at your situation. You want to use a good like methodology. You want to think about the circuit. Wiring schematic is critical. You want to know what circuit is supposed to work normally and what circuit is getting fed when it shouldn't be and causing a symptom. It doesn't have to be an engine control thing. It could be an accessory. It could be power windows. It could be anything else. This is a way we can use more than one medium. I thought about an ohm meter. Ohm meter is good, but it only can give you information on 1 channel. This kind of opens up our horizons, and we're able to monitor 8 channels for bleed over when they shouldn't be. Nonetheless, hope you enjoyed it, and you're going to use this to your advantage. Hopefully it's not your everyday situation, because I know I wouldn't want to be in this situation. I have been, and it's not fun. But anyway, signing off. Take care.